Hello students, welcome to lecture 2 of Aerodynamics, Fundamentals of Aerodynamics. In this lecture we are going to study about aerodynamic forces and moments. So we know that if there is an airfoil here, then there are two forces that are acting on it. That is pressure and shear stress. So one is the pressure and one is the shear stress. Shear stress is tangential to the airfoil. That is the shear stress. And I'll tell you about this thing. One, there's a thing like S. This S denotes the location of any arbitrary point A, and this is point. This is shear stress. Yeah. So after that, we now know that there are two forces acting on the airfoil, that are pressure and shear stress. Now coming to the real flow that will be happening over an airfoil. So we have an airfoil like this. Then we have some free stream velocity coming here, v infinite. So this v infinite will generate pressure and shear stress over the airfoil. Now two things will result from these pressure and shear stress, that are moments and two things will act. One is the moment. So this is the moment. About any point you can take. I've taken a gentle moment over the airfoil. And the second thing that will be resulting from this free stream, from this air that is coming to the airfoil, would be the normal reaction. This is the normal reaction R that will be happening to the airfoil. Now coming to what other quantities, how do we resolve R into other quantities so that we have manageable variables for calculating the lift and drag. So first of all, R is split into two components. So I'll make this diagram here. It will be easy for you to understand. So if there is an airfoil here like this, and we have C, this from here to here, it is C chord, and this is the free stream velocity that is acting. Sorry, this is the free stream velocity that is acting on the, this is V infinite, free stream velocity. So what all forces can we resolve R into? So there is an R acting here. There is a R acting here. Then we can resolve it into two, firstly into two components, that is lift and drag. Firstly we can resolve it into lift and drag. This is lift, this is drag. Then we can resolve it also into normal reaction, normal force component of R, which is component of R perpendicular to C. So we can make, I'll use my green pen here. So this is the component N, and if I take a perpendicular to the chord, then that will be A. So I'll take component perpendicular to the chord. Then this force is A. So that's the diagram here. This alpha is angle of attack. This is free stream velocity. That is if the plane is moving forward, then this V infinite is what the velocity of the wind is when it strikes the airfoil. Now after that, we have what is the geometrical relationship between N, A and lift and drag. N we all know is normal to the component of R, which is normal to the chord. Chord is this one. N is this one. So the geometrical relationship or you can say that the governing equation for this diagram, that's is there. It is, I'll write it down, L is equal to N cos alpha minus A sin alpha. L is equal to N cos alpha minus A sin alpha, and drag is N sin alpha plus A cos alpha. So that is the governing equation, geometrical relationship, that is that describes this diagram. Now coming to integration of pressure and shear stress distribution to obtain aerodynamic forces and moments. I'll, I'll just now rub this one. I hope you have noted it down. So now coming to the integration of pressure and shear stress distribution. So the next topic is integration of pressure and shear stress distribution to obtain aerodynamic force and moments. So the diagram here that is there is this one. So there is airfoil like this. The chord is horizontal. Unlike the previous one, this chord is horizontal, and the free stream velocity is coming like this. This is the free stream velocity, and this is alpha, that is the angle of attack. Now we will have two arbitrary points. This is the leading edge, this one is the leading edge, and this one is the trailing edge. Now coming to the upper portion, we know that we have pressure and shear stress distribution over the whole body. So at any point, take say A, from this to this, we will have two things. One is pressure and one is shear stress. So there is the pressure here, which is normal to the surface here, and there is this shear stress here, and this is the pressure here. This is at an angle of theta, so this one is the shear stress, and this is also theta. So we have this. This is called point A. The part from this to this is what we call SU. S is the distance, and U denotes the upper surface of the airfoil. Similarly, for point B, we will have in the lower surface. Similarly, in the lower surface, this is point B. We will have two things. One is normal to this reaction. This is P U, and one would be tangential to the airfoil, that would be tau L. Sorry, this is L. So these will be acting at an angle theta. So this would be acting at an angle theta, and this would be acting at an angle theta. So that is the diagram that shows the integration of pressure and shear stress distribution to obtain aerodynamic force and moments. Now, what is our interest? What is our aim? Our aim is to get the total normal force and total axial force. So I'll rub this down based on diagram. Our aim is two things. First, to get total normal force. To get total and second, to get total axial force. This is our aim. So now I have written two equations here. This is normal force here, and we have an axial force here, normal and axial force. And this dash or prime means that this is per unit span. These two equations are per unit span. So when we have two integration here from LE to TE, from leading edge to trailing edge, then we will get the normal reaction here, the normal force, and the normal force here and the axial force here. Now if we substitute these two equations in our number one equation, this is 1, this is 2, this one is 4, sorry 3, and this one is 4. So if we substitute 3 and 4 in 1 and 2, we will get the total lift and drag. So that was all for today, guys. I hope you have gained some knowledge from this video, and if you have done so, please do give a like, subscribe, and if possible share it among your interested friends. Thank you.